welcome to this channel, and this is oxidation reaction part 3. So in this video we are going to discuss that Wacker oxidation and Jones oxidation and some Collins reagent. Okay, so let's start. First we start to the Wacker oxidation. Okay, so let's start. This is Wacker oxidation. Okay, now what is the reagent of Wacker oxidation and how it works and what will be the mechanism? I will do it and I will show you how this reaction proceed. Okay, now see the reagent. First of all, the reagent is in Wacker oxidation is palladium chloride, and there is a catalytic amount of copper chloride. This is oxidation state 2 of copper, and some in aerial oxidation, that is not oxidation, actually aerial oxygen, that is aerial oxygen and water. Okay, this is your overall reagent. Now see, this is very much regioselective reaction. Okay, so this is regioselective, and how I am saying it, regioselective. I will tell you how. The overall mechanism you can easily predict, or you can easily say that this is regioselective. Okay, so regioselective means a region specific. That is, if this is a type of Wacker oxidation, will generally convert terminal alkenes to methyl ketone. Okay, so what is terminal alkene and what is methyl ketone? I am writing over here. So see, terminal alkene means if a compound like this one, this compound has two type of double bond, or all two type of this compound have containing two type of double bond, that is this one and this one. So these two are not terminal. Is one is terminal, another is not terminal. So terminal means that is end, one end. So this is called the terminal. So this is terminal alkene. So Wacker oxidation selectively oxidize this terminal alkene to methyl ketone. Okay, so we all know what is methyl ketone. That is methyl ketone like this, and there is other part. So this type of compound, if we do this Wacker oxidation on this type of compound, then product should be like this. Okay, so this is your overall product. And now let's see what is the mechanism of this Wacker oxidation. Okay, see the mechanism. Now the mechanism, first we taken as a, I take it a alkene like this, and we have given this palladium chloride. So okay, this is palladium chloride. Okay, now this double bond will attack over this palladium. Now this palladium, here is the positive, and here is the palladium is attacked and attached to this carbon. Okay, now in the medium we have done this water in the medium. So this water will attack over this carbon. Okay, I am writing as a minus of H plus. Okay, so the product will be like this, Cl. Okay, so there is a Cl is leaving, so this Cl is not attached with it, so only this one Cl. Okay, so this is your overall product. Now there is an important thing is that there is a beta elimination will take place after this product formation. Okay, so what is beta elimination? So what is the position? This is alpha and this is beta. So you have this hydrogen over here. So this hydrogen and this overall PDCl, this overall group will be leave from the system as and beta elimination will take place, and there is a formation of alkene. Okay, so like this. Okay, so that this product will be formed, and this product actually totally not removed with this not totally removed, but it is somewhat attached to this palladium, and I'm writing this here. This Cl I'm writing this here as a ligand or Ln. Okay, Ln means not a this Ln means only just a ligand. Okay, so now after that there is a one more important thing, that is this step is called beta elimination. Beta elimination. Now after that there is a formation of after that there is a one more important part is that is 1,2 insertion. This insertion is typically that is called migratory insertion. That is migratory insertion. So what is migratory insertion? So migratory insertion is nothing but this hydride will attack over here and this bond will attach to this palladium center. Okay, so now this is your product. This center is attached with the palladium and aniline plus like this, and here you have the hydrogen over here, this carbon. Now then the final step which is happening here, that is this bond will go here and this will leave from the system. Okay, this total part will leave from the system, and this is also kind of reductive elimination. Okay, so this is type of reductive elimination. So in this step you can call it the reductive elimination. Reductive elimination. Okay, so this is reductive elimination. So after that you get the product like this. So this is CH2NH and this is your overall product, and this is your methyl ketone, and see you are taken this type of terminal alkane to get this product. So this is how the overall reaction mechanism proceed. Now let's take some example of this, and you already know the residual selectivity of this overall Wacker oxidation. Now let's have I am written this kind of structure over here. So this is your alkene, and this alkene will convert it to this alkene. So this is not one, this one actually. Okay, so this is your overall product. If we done this in the of this compound in Wacker oxidation, we'll get this product. And similarly this, there you have, I'm already said that is the Wacker oxidation selectively oxidize this terminal alkyne to methyl ketone. So there is a two different type of two different type of alkene is present. So here you have the alkene and here you have the alkene. So if we use Wacker oxidation on this type of compound, then the selectivity or residual selectivity will occur. So this alkene group is reacted, and this alkene terminal, this is terminal alkene. So this terminal alkene selectively oxidized to this terminal alkene to this methyl ketone. So this part is called the methyl ketone. Okay, so this is how the overall mechanism proceed, and this is the overall probable mechanism of this reaction. Now this is Wacker oxidation. Now let's take another oxidation which I said earlier, that is Jones oxidation. Okay, so what is Jones oxidation? Jones oxidation. Now what is Jones oxidation and what is the reagent of its of this type of oxidation? So this type of oxidation generally used in this Jones oxidation, that is CrO3 and or the other salt of like dichromate, potassium dichromate, or sodium dichromate, like this K2Cr2O7, or its part called Cr2O7 2-. Okay, and this is the overall reagent, and you have to put some acid. You have to put some acid and water. Okay, and you have solvent. That's generally the solvent which is used in this Jones oxidation. That is acetone. Okay, so this is the Jones oxidation. Now let's have a look at the mechanism and how it works and how the overall mechanism proceed. Okay, let's have a look of the mechanism. Okay, now this Cr2O7 or this CrO3 and how the reaction proceed. Now this Cr2O7 I am written like here, this Cr2O7 to minus, this will first react with water. Okay, so this will first react with water and form this one. Okay, and this generally this will remove the H plus from the system, and there is a formation of this one. Okay, not remove, actually this part is removed from the system as a kind of water. Okay, so this type of this OH, actually this lone pair of electron takes the proton, and this will leave from the system as a water. You can see here that is minus of water. So this is how the overall CrO3, and this CrO3 has now you have put some alcohol, so which will be converted, that is alcohol, that is I am taking as a secondary alcohol. This will convert it to this, that is a ketone. Okay, so we will take a alcohol, that is 2 degree alcohol. Okay, so this 2 degree alcohol, so oxygen has a lone pair of electron and it will attack over this chromium center, and oxygen bond goes back to the oxygen atom, and there is a formation of this one OH. There is a hydrogen over here, and this one double bond O, and this is your OH, and this is your, okay, so this is how your intermediate like this. And after that, the removal of this group, this part will remove in as this one takes the proton over here, and the finally you have get that your final ketone, that is this one, prime prime prime. Okay, so and your final product is like this. Okay, so this is how your final product looks like. Okay, so now see, this is your overall mechanism. Now there is a different type of extension, different types of reagent, that is PCC, BDC or Collins reagent like this. And also Collins reagent is nothing but chromium trioxide and pyridine complex. This is I'm writing over. Okay, one more thing is that in the Wacker oxidation, that is what is the role of this CuCl. Okay, so CuCl is nothing but this copper is in +2 state, so this copper 2 in will react with the oxygen, aerial oxygen, and it will reoxidize this palladium to palladium 0 to palladium 2. So here in this step the palladium is free, so palladium is free, that is you get this palladium in 0 state. So to reoxidize the palladium to palladium 2, this CuCl2 has a major role. Okay, this is the overall concept. Now let's go to the Collins reagent. Okay, Collins reagent. So what is Collins reagent? Collins reagent is nothing but that is only CrO3, that is chromium trioxide, and pyridine complex. It is pyridine complex. Okay, so this is how your Collins reagent. Okay, so now there is one more thing, important concept is that is PCC and PCC. And now what is PCC and what is PDC? So PCC is nothing but pyridinium chlorochromate, and this PDC is pyridinium dichromate. Okay, so I am written this structure over here. The PCC is this is actually a salt. Okay, so PCC is nothing but CrO3 pyridinium. This is called pyridinium salt, and this is called chlorochromate. Okay, so this is how the overall PCC, and here is a PDC. Okay, so this is PDC. So PDC is pyridinium dichromate. Okay, so pyridinium dichromate, this is your pyridinium salt here, and Cr2O7 like this. This is your dichromate part. So this is how the different types of two different types of reagent, and let's have a look how this overall reaction works, how this reagents are works. Okay, so we take an example like this. Okay, CrO3 and use pyridine. This is actually Collins reagent, and you have to put some solvent here, and this is the rest part. Okay, so this is a primary alcohol nearest to this epoxide. So this primary alcohol will finally convert it to this aldehyde. Okay, so alcohol is converted to aldehyde. Now there is one more important concept, is that if we use the PTC. Now let's take a complex like this. There is your OET, and this is your OH, and here is your rest part. Okay, so if we use in this type of complex, if we use PDC, so what will be your product? The product is nothing but this type of ketone. Okay, this other part will remain intact. Okay, so this is how. Now one more important interesting thing is that if we use this type of allylic alcohol, like if we take this as a allylic alcohol, and here is your OH, here is your Me. Now this is allylic alcohol, and now this allylic alcohol is 3 degree. So if we use in this 3 degree alcohol if we use in PCC, so what will be your product? So there is no hydrogen, 1 2 3, and this is 4, there is no hydrogen, so this bond so here is the oxidation is not possible. So if we use when we use this PCC, then this overall part will rearrange. So here is a possibility of 3,3 sigmatropic rearrangement, and I will show you how this overall 3,3 sigmatropic rearrangement will proceed. Okay, so now the structure we all know. So what is the PCC structure? The chlorochromate part, we are taking it like this way. Okay, so now this is, and there is oxidation. This oxygen has a lone pair of electron, and this will attack over this here, and this bonds will go here. Here is your Me, it's a double bond, here is a above the bond. Okay, so now this Cr, this is OH, is a double bond O, and here is a double bond O. Okay, this is your overall. Now here is a possibility of 3,3 sigmatropic rearrangement. Tropic rearrangement. Okay, now see, if we numbering from here, that is 1 2 and 3, and now this is 1 2 and 3. Now here is a possibility of this oxygen has a lone pair of electron, and this will attack here, these bonds will go here, and this will go here. Here is an important thing, and this compound is actually very much important for competitive exams. Okay, so this is your overall OH, and this has your double bond, and this will convert it to like this. Okay, now you have this hydrogen over here. So now this hydrogen will go here, and this will you remove from the system, and you get your final product like this. That is this one and this one. So this is how the overall product. Okay, so this is very much important for exam purpose. So this is the overall mechanism. And one more thing is that if a compound we are taking as a compound like 2 degree alcohol, if we use one step, actually not one step, that is 1 mole, use like this, so this will convert it to this alcohol to aldehyde. If we further use of this, then your ketone finally form your acid. Okay, this is called over oxidation. So this is your over oxidation. Okay, so So this is overall your Jones oxidation and your Wacker oxidation. Okay, I think I will cover all those topics regarding to this, and if you have any query of this regarding to this topic, you can comment me on this video. Okay, so that's it for this video, and thank you so much for watching.